Welcome to today's webinar with the very catchy title, How to Achieve plus 10% OEE in Chemical Manufacturing.
And we see people are still joining here. When we looked at the registrations, we really had people from all over Europe as well as from the States. So thank you for tuning in. And while people are joining, we will get started. Maybe for housekeeping on purpose, we kept that really open so we can have a good conversation and Q&A at the end of the session. We will also take a recording from this so that we can share it with you afterwards. But while we are holding the webinar, just keep your microphones muted. And yeah, I would say let's dive right in. And introduction-wise, my name is Veit Hora. I'm leading the operational business here at Eschbach. Eschbach is, if you don't know it, a software as a service company. We are focusing on digital manufacturing. And we make a product called Shift Connector. And I had the pleasure to be part of a range of global OEE implementation projects in chemical manufacturing. And that includes, for example, Bayer Crop Science, Covestro, or Albemarle. And I'm really looking forward to share learning points from these projects. But I'm also happy to present today together with you, Thea.
Thank you very much. My name is Thea Precht. I'm a process optimization expert at Eschbach. But before I joined Eschbach, I worked as an assistant plant manager and process optimization manager at Röhm. And I worked in 4 different plants across 3 sites in 2 countries. And in all of these stations, I focused on improving chemical manufacturing processes, but also digitization projects and communication projects. And 1.5 years ago, I started at Eschbach and have now the chance to combine these passions like improving processes, but also digitization in my new role as a consultant here.
Super. And let's try to get out the best for our audience in the next 30 minutes. And then we do our live Q&A. So quick run through of the agenda. Why OEE? So why does it matter today in chemical manufacturing? Also, what holds it back? Second, right? So patterns why chemical manufacturing maybe isn't as productive as it could be. Improving together. So the basics for any improvement, it's always the way of working and leadership. So Thea is going to talk about this quite a bit. And then from silos to insights, how you build your OEE data foundation, empowerment in action. So we're going to look at real life customer examples and then also talk about how you can take actions. So we have prepared a 5-point checklist of how you could start with a simple OEE tracking right away. And let me kick this off with a question. Why does OEE matter now, right? In particular in Europe, where chemical manufacturing is down by 15% on average for 3 years in a row now. And a couple of answers. And first of all, OEE improvements can be cheap, can be really affordable, right? OEE increase can come from better scheduling, better cleaning routines, better communication, but not necessarily capital investment, right? Then the chemical manufacturing landscape changes. There's obviously more cost pressure, in particular at the moment. There's shifting demands. And that means you might need, for example, you need to run fewer lines. You need to change your batch sizes. You might see, for example, a new type of quality issues, which you didn't have before because you're now running at lower throughput rates on some equipments. So all this needs continuous improvement. And OEE, and that brings me to the third point, OEE is a fantastic KPI for continuous improvement because it really helps you to set targets to drive your leadership. Thea will also talk about leadership. And then you can measure with OEE if you're winning or if you are losing. And talking about the business case for OEE in chemicals, and that's really very simple mathematics here. But just think about your manufacturing network, about your plant, and think about the daily and hourly value creation which you have there. So how much is it per hour when the plant is up and running at your typical best rate? Euros, US dollars, doesn't matter. And some would say maybe 10K, maybe 20K if you're running a really small asset. But some others might say maybe it's 150K per hour. Maybe you go even beyond 300K per hour. It really depends on your process and on your asset. But the bottom line is that if you add those up, if you have just 1% OEE increase, then can make a huge impact over the course of a year.
And just because we have such a diverse audience, very, very quickly, a little bit of theory up front to make sure we all talk about the same. So when we talk about OEE, we talk about overall equipment effectiveness. And what OEE does, it measures your plant, your line, etc., against itself, against its best possible performance. And the questions with OEE is, how much of the time which was planned for production was actually used to make good product? So how much downtime did I have? How much speed or performance did I lose? So did I produce as much in as short of a time I wanted? And how much of good product did I use? Did I have any quality off-spec issues? Did I have to rework my product? And all of this combined gives you your OEE number. And with that, let's talk about what holds back OEE and how we can fix it.
Absolutely. And if we look at all the projects we've been on here, you and I, we had a discussion about it. There are really common productivity blockers. And the obvious one is that you might have reliability and maintenance issues because maybe there's a lack of preventive maintenance. But the key here is that maintenance very often depends on input from operations, from the operating shift teams. And that can be also delayed or incomplete, so it could come also from communication issues. Maybe you have not the ideal operating practices, and we all know this. Like there is the A shift team and the B shift team, but the A shift just knows it better, right? Once they're on shift, they start changing the set points and the process parameters. There might be things like missing information in shift handovers, or there might be also knowledge which is gone because people left for retirement. Another reason might be communication, coordination gaps. So it could be poor alignment with planning, with lab, with maintenance, maybe with site logistics if you run on a larger sites, and where you might have an issue with cross-functional collaboration. And then the last one is a big one. Data misuse or underuse. What do we mean by that? Very often productivity data is collected somehow. Very often even you have some easy formula how to calculate your OEE, but that's then just used as a management report. But what you really want is you want to use your data for continuous improvement. So of all this list we were showing, no matter where your biggest improvement opportunities are, at the end of the day, what we can say is it always involves people. In a typical chemical plant, you have 50 to 150 people working at the plant, and they are in different shifts, they are in different departments, and they are in different hierarchies. And OEE can really be your glue, your driving KPI of bringing those people together for improvement activities.
And that's also why it's really important to think of OEE improvements, improvement projects in general, as a team sport approach. It's not an individual that will do this. And so you can think of your team as an elite sports team. And just like in a soccer team where you need defenders, strikers, goalkeeper, everybody in your plant has a crucial role. And not everybody is front of house. Not everybody is actually on the field playing. Don't forget the support staff. When you think about a sports team without a physiotherapist, an equipment manager, or even a bus driver, without these people, you will not be at your best performance. And it's the same in your plant. without your maintenance staff, your lab staff, your administrative staff, you will not be at your best. You need to make sure that everybody has the data they need to succeed. And each of the roles in your team has different needs to succeed, but also has different impact on your OEE. And as a team, you can only succeed if these team members have what they need and if they communicate with each other. And really important for this to succeed is to make your OEE comprehensive. Related to the roles, operators, engineers, management, different roles have different impact and different knowledge when it comes to OEE. So make sure that everybody understands what OEE is. And if you have to use analogies to break it down to them, don't let OEE be this one white collar number that's reported once at the end of the month to management that nobody really has an idea about. Like, you can explain it as a car, like, is my car available to drive? How fast does my car go? And how well does it run without any issues? And there you have your availability, performance, and quality, for example. And in general, like, use clear communication, individual to the adversary. And then once you have this, and you also trained your people on what OEE is, provide regular updates, for example, in team meetings, in morning meetings, like create a feedback loop so that, first of all, your operators see what OEE is, but also how, for example, their performance or the engineering's performance has an impact on this. Include every stakeholder in your plan to create ownership. Make sure they understand the impact, but also the impact OEE has on their work. So, for example, you need an investment for a maintenance project, and you need arguments on how to get this budget approved. And one way can be OEE. If you can show, for example, you want to replace a pump, you want to, I don't know, introduce a new piece of equipment, and you can show in your OEE, for example, this piece of equipment was one of my top loss codes over the last year, why we lost product. And this way, OEE can be used also to your benefit. Whenever we talk about KPIs, be sure you have achievable goals. Use industry benchmarks to set aspirational but realistic targets. And you probably all know about SMART goals, like keep them specific, measurable, relevant, etc. And then once you have these goals, align your team and your departments on these goals and make sure everybody understands how they fit into this plan. Customize your OEE metrics to fit the specific needs and goals of your plant or production line. And I mentioned it in a sentence before, training. Make sure everybody understands what you are talking about. Because only if they understand, you can get the ownership from everybody in your process that you need. There is a interesting paper, it comes more from the psychology side of things, from Isaac Ascent from 1991, and it's called The Theory of Planned Behavior. And it shows that people are more likely to do something if they want to, if they feel supported, and if they believe that they have an impact. So what is the attitude? Like, do your workers believe improving OEE is valuable? For example, it means that they have less stress, more pride, it secures their job. So there you need a framing from leadership, like how the attitude can be modified. Is there a culture that values OEE? So is there a subjective norm? Is everybody contributing? Or is OEE just the issue of this one engineer who then gets the blame and the celebrations if OEE is bad or good? Or is it a team sport? And also the perceived control that they have. So, for example, your shop floor, are your operators able to give in ideas, like to say, hey, I see something in our process, I have an idea how we can make this better. Is this heard? Is this seen? Do they get feedback on this? How does plant management take improvement ideas serious? And all of this frames intention and behavior. And then once you have your team, your communication aligned, then you have to look at how do I deal with my data? How do I get from silos to insights and create transparency? And we talked about stakeholders before. Identify the key stakeholders in your plant, in your organization. Based on the role, they need different data, different aggregations, and have different impacts. And prioritize the KPIs for each stakeholder and make sure that they get some form of visual or overview, how they can, for their role specific, see how it's going. Have timely data insights. Obviously, real-time data is the goal, like have real-time data. But if that is not possible, allow timely data, like maybe once a day, just to give a feedback in the morning meeting. Hey, yesterday our uptime was 95%. Or yesterday our top 2 reasons why we had to stop our process were these 2. OEE is not just this number, it's a valuable tool. Make use of automation, automated reports, alerts, and notification to streamline your loss accounting. Not everything has to be done manually by your operators. You can make their life easier as well, so that they don't feel OEE or loss accounting is this burden that they now have to do for management. And when we talk about automation, we also have to talk about integration. Make sure that your OEE data is integrated with other parts, with operational data, for example, to get a holistic but still comprehensive view of your plant process. And then once you have all of that in place, also make sure that your interfaces are user-friendly. We all know a software that we don't like interacting with because it's slow, because it's bulky, because it's not intuitive how to use it. That's not what we want. Use somewhere where for your engineers, it's easy to get the data out. For your operators, it's easy to get the data in. And also make sure that they have ideally a mobile access to this. So if they are somewhere in the plant, or if in these days and times, they might be working from home for a day because they only have meetings, they can still access their OEE data and see what's happening in the plant and react to anything that comes up. And last but not least, make sure your data is first of all accurate, because there's no point in improving if your data is not accurate. Make sure it's reliable so that what you see is really what you have. And really important, make sure your data is secure. So if you use digital tools, make sure nobody else can benefit from your data outside of your organization. And when it comes to data, we tend to think, oh, the more data is good data. No, not necessarily. Nobody likes to be overwhelmed by information, by data. So make sure you have a comprehensive data collection. Make sure your data is aggregated in a way that everybody sees what they need to see without having to sift through tons and tons of records. You can see if you can make use of historic data, but be careful, make sure that you know that this data is correct and relevant to your needs. And also make sure you have diverse data. So not just machine data, also operator inputs, also inputs from procurement, environmental conditions. Maybe your process runs different in the summer than it does in the winter. And when you have all of this, don't die striving for perfection. Better start and get better than wait to be perfect and then start. Like, it's a classic 80-20 approach. So have a pragmatic and practical approach to data collection. Make sure you have insights, actionable insights, and then see that you start an iterative process to improve, and also have a tolerance for imperfection. Nothing, like we all know our process data, it's never perfect. But make it as good as it can be. And then make sure that you aggregate the data depending, for example, for your different tiers. Your shop floor needs a different view than your department, than your plant management, than your business unit. And between all of these tiers, have a good communication flow. We want to deliver the right information to the right person at the right time to make the best decisions. And if you have data silos, this really slows down your plant and your processes. The same if you don't have a good communication between your departments. So for example, in the morning meeting, you focus on how much product did we make, what was the uptime, focus on delivering actionable insights for an immediate and effective action, and a transparency to quickly identify issues and make good decisions to enhance your productivity. Then on your weekly OPEX meeting, OPEX circle, for example, you look more at performance KPIs. Maybe you look down into the Paretos. What are my 5 whys? What are my 5 top reason codes, top function locations that keep causing me problems? And there you can integrate your system to consolidate data. So maybe not just production data, but also maintenance data, and contextualize your data. And then on the site and business unit leadership level, you're more looking at an alpha mix or at your S&OP compliance. And between all of these levels, it's really important to create a collaborative culture. Like OEE, like operation, improvement, innovation goes in both directions. And it's really important to think of this, as I said before, as a team sport.
Super. And let's look a bit at the architecture behind this. And we are not going to be too technical, but we also want to give you an overview of what is a good best practice, how you organize your data collection. And I would say a key learning point from the implementation projects we had so far is when we really start at the bottom is that we need to have what we call here a clean process data layer. So that's typically where your historian sits, like your Aviva Pi system or your Aspen IP21, or we will see more AWS TimeStream and other solutions in the future, where you typically have your units, like your product, your batch, your flow rates, your batch start-stop information, maybe your error codes if you have that. That's what we call clean process data. And there's also a segregation of duties. So someone needs to be in charge that when you replace a sensor, change something on the OT layer, that it's adapted in that process layer and this process data layer so that the whatever OEE solution you're using always gets the same clean maintained data. And then there's another layer, which is what we call the collaborative OEE layer. And this is where you then look more at business data and context data. So this is where we will maintain targets, so master data per product and per unit. How fast can this product run on this equipment? This is where we have the live view of production losses towards a control room board operator or outside operator who is maybe using a tablet. And this is where we also do the shift-based loss accounting. And where we will see the daily OEE reports for the shift and for the morning meeting. And then on top of that, we have the plant management layer. They would receive a monthly OEE report, which can be an extract from the collaborative OEE layer. And where such information then also is blended with my production planning so that I can get out something like a produced to plan report, which Thea also mentioned earlier.
And then there's another player that becomes more and more popular, more and more hyped in a way, and that's AI. So AI-powered assistants. And yes, it is a buzzword, and there are lots of solutions, and there's maybe also some hesitation to use it, especially on the shop floor. Oh, AI is going to replace me. No, AI is a super powerful tool that can help you. And it can help you, for example, to analyze large data sets and identify patterns. They may not be immediately obvious to humans. AI can support your decision-making based on historic data. It can be especially useful during weekends, night shifts, to have an AI assistant that knows all of your historic data and can contextualize this. AI is also super powerful for knowledge transfer. We talked about people leaving for retirement, but also in general, like people leaving and taking their knowledge with them. And AI can help you to keep this knowledge preserved in your plant. And then it can help you in your continuous improvement process. For example, it can support your root cause analysis. Faster troubleshooting, better continuous improvement. This is what makes our life easier. And with that, let's have a look into our module, Shift Connector Smart Search, for example. So you can use AI to analyze productivity losses. And here we have something from our OEE accounting. The process engineer gets told that there's an issue with quality impacting the Q pillar of your OEE losses, and they start to look into the issue. And they've been told there has been a color deviation. The color is darker than usual, the product is darker than usual, and they feel there might be a pattern. The AI engineer can use a simple search, product, darker color, and the search engine understands the issue and brings up all historic records which have a similar context. It uses natural language processing to identify similar issues, and it can group these issues by solution. So the headlines we see here are AI generated, but the records that you see underneath, they are and have to be real records that were captured by your production team in the past. And that gives you an overview of like what can be related to this dark color issue, for example.
Super. And Thea, you started making it a bit more practical, and that's what we will proceed doing. Maybe just let me give you a short summary of what we discussed so far. And I mean, what we see here is really also the pattern we've observed again and again in successful OEE implementations. And just starting from the bottom left, really briefly with the basics is first, measure your losses, but it's just the beginning. What you really need, and that's the second one, is context, right? So process trends and reactors and machines, they don't know the whole story. It's the people working on the night shift. They really know what happened. And their insights, that's really the gold dust on top of your OT and process data. And obviously it's about work processes, about leadership. Dashboards are great, but just another dashboard is not the solution, right? So dashboards need to be tied to clear targets, and they really need to be built into your PDCA cycle routines and your continuous improvement routines. Otherwise, nothing will change, right? The fourth one is, as Thea said, make sure that the plant management cares about improvement ideas. We talked about the Kanban board. So we need to have a place where we put improvement ideas, and we need to get feedback from plant management, whether it will be implemented or not, whether it's a good idea, whether it makes sense. And last but not least, it's about actions and improvement there. It's also not a one-man show. I mean, chemical manufacturing is typically 24/7. Communication is just more difficult than in a normal office environment. So what you really want for your team is a platform to exchange and to track actions across shifts and departments. Shift Connector obviously is such a platform, but sometimes an Excel on SharePoint can be a starting point as well. Now we said we're going to talk about example. So one real life case here is Bayer Crop Science. We are very proud to work for Bayer Crop Science. They are using Shift Connector globally, and there's a wonderful example from one plant in Dormagen, where the team really had a major success and they improved the OEE by 10%. And the head of active ingredients manufacturing, Dr. Udo Snyder, actually posted a video on LinkedIn on this particular success. And the setup here is tactically, and speaking from the IT world here, is they're really getting the data from an Aviva Pi system, and they're feeding that data into Shift Connector, just like the architecture we showed a couple of slides ago. And Bayer had been using the Shift Connector platform for a while, in particular also in that plant in Dormagen, and they were really accounting losses on every single batch. Whenever they had a cycle time deviation, they were doing loss accounting. Now, the plant manager reviewed those losses to find patterns. And in those loss recordings, they now found an interesting set of variations, which they really wanted to improve on. And they used other tools, such as Trend Miner as well, then later for the more detailed multivariate analysis. But they started really then making modification to the operations. And here we really need someone from chemicals who can explain what they did.
Yeah, it's not, interestingly, it's not even as much a chemical issue as a physical one, but yes. So what they found looking at the data was that some of their batches went longer than they were supposed to, than expected. And they wanted to go and try to really understand what had happened. And the more they digged into the data and analyzed their losses and also the conditions around it, was that they saw that a certain step in their reaction was sometimes too cold. And this led to an increase in viscosity. So their product in the reactor was too slow, was too viscose, too high viscose to be properly mixed. And that slowed down the batch overall. And once they identified it, the solution was really simple. Preheat the reactor for this step. Make sure that it is at the right temperature when the product gets in to avoid this like viscose layer on the outside of the reactor. Yeah, massive one-off improvement with a really simple step. And it involved like having the data that they needed, having the context of the losses, like, okay, the loss is it's too slow. The context is it's because we have this high viscosity, and we have the high viscosity because it's too cold. And then using and reviewing the data and working as a team to implement the improvements.
And going maybe a bit further here, how does it look like a generic, let's say, demo of batch loss accounting, the way it's been used in several of the projects we did, including the one we did for Bayer Crop Science. So what we see here is, first of all, a range of units, and on each of those units we have batches, and it's very simple color coding. Green one are those batches which are within their intended cycle time. Red ones are those which are exceeding the cycle time, and the orange ones are those where we need to capture losses. And this is what the short demo is about, right? So maybe we have in this example a batch with a certain phase that took longer because we were waiting for a sample from the lab. And that maybe took longer because of a missing department alignment in the first place. So we are recording this, and it's now part of my loss database where I'm combining data from a process historian with operator input. And that starts making sense when you put yourself in the shoes of a, let's say, operational excellence engineer, process engineer, when they return on their day shift and when they look at the losses. They might want to switch the view into a process control chart, look at the outliers here, and there we have it. That's the sample which took too long. So that's a specific view in one batch, but I think when we work with data, it's all about aggregating data. That's just one view. There's obviously a whole other range of options. We were showing them briefly before, like the OEE waterfall is a classic, a Pareto chart, either by reason code or by the function location, which comes from your CMMS system. And obviously for batch processes, Gantt charts are everywhere, and they are really important, right? So once you have your data right, visualization isn't the biggest issue. The data, getting it right, is the first thing to do. So before we get to the checklist, one more example, because we were talking a lot about batch processes. We also want to dive into a continuous example here. So this is where we are looking at a flow rate, which is coming from, in that case, the Aviva Pi system. which drops to 0. So we have a downtime, and that's my trigger point to also record a loss here on that process. And in this example, we are saying maybe it's an issue with the pump, which stopped because we had product buildup at the sensor, and maybe it just needs regular checking with the inspection rounds and regular cleaning, right? So, last item before we get to the Q&A is we've been looking now at a full-blown OEE solution, but we really want to now look at 5 really simple actions for you, which are easy and quick to apply for OEE improvement. And that's for you, Thea.
So it's really about doing small steps, baby steps. First of all, start with recording your downtimes. Speed losses are hard to track. Quality losses are sometimes harder to track, especially if there's a delay between production and you get the quality data. So the first obvious place to start is downtime. And yes, it can be a specialized tool. Obviously, shift connector is the best. But no, it can be super simple. It can be an Excel spreadsheet. It can be a SharePoint, whatever. Collect the downtimes and make sure you add the reason codes to it, like add the losses, like why were we down, to get an understanding and an overview of what's happened. And once you have that, make an Excel chart or Power BI, which you show to your operators, either on the shop floor or the control room. Ideally, you have a screen where you can just put it up for them to look at. But if you don't have that, it can also be as simple as to print it out once a day, once a week, to show how your uptime develops over time so the operators can see their impact. And make sure you use your data. So we collect all this data, but like, what do we do with it? Discuss actions on loss reasons in a morning meeting, in a weekly OPEX, make it part of your communication. And then talk about corrective and preventative actions. So how can we avoid this loss in the future? And Veit mentioned it before, your team has ideas. It gives them a place to put them, the Kanban board. It can be really simple. Only make sure that there's a point where plant management reviews it and can give feedback on it. So whether it's accepted or declined. And also, if it's declined, why it's declined. Like they want to see that their ideas are being seen, are being heard, and that is valuable. Even if you can't do every improvement, make sure to let them know why. And to loop back to the analogy with the sports team, celebrate your wins, celebrate your best improvements. Recognition is super powerful, and it can be as simple as, hey, we had a new production record, we sponsor a breakfast for the shift. Everybody loves free food. It can be that you have a dedicated improvement project, and at the end, during the project, to create identity, but also at the end, give out top performer t-shirts to the achieving team, make merchandising, make them feel that they're part of the team. And all of these steps, they don't take a lot of work. Like you don't have to spend all of your times on OEE. Just make it part of your process. And I don't know, it can be like it less than 2 days per week per plant is what I normally see that already has like a huge impact on improving OEE.
Super, and I hope that's meaningful for you. And let's also open up for the Q&A and really have it your way. So if you prefer to put questions in the chat, we will read them out and answer them. But I mean, as you can see, it's a team session, so you can just unmute yourself, maybe turn on the webcam, and we can have a discussion. So both is equally possible. Yeah, let's just see what your feedback is. One of the questions which were by one of our customers who is attending the webinar today, which is great, is whether we will share the deck after the webinar. And yes, we will obviously share the recording. Thank you.
One of the things I learned from transitioning from chemical industry to software industries, that's not a PowerPoint presentation anymore, it's a slide deck now.
Ah, okay. It's a good one. Yeah. Well, if then not really more questions, I would really like to thank everyone for joining. We had quite an audience today, and yeah, appreciate your feedback. Also, if not in this round, drop a comment by email or here in the chat. And yeah, thanks again one more time for joining.